This is the torque of lever lab. Read through the introduction and then read through the procedure. This is a setup as you can see in your screen. So all I need is a meter stick. So the number of meter stick I'm using is number 1. So you probably want to write that down into your data collection. Number 1 is the number of the ruler. And before the activity or before the lab, I did using the balance to measure the mass of the ruler, which is 94.71 grams. Using the strain to hand up the ruler to find out the center of the gravity of the ruler. As you can see, the ruler is pretty balanced at this moment, and as I'm going closer to read the number on the ruler, which is 50.1 centimeter. So that is the center of gravity. So problem number 1, I need to hand 100 gram mass at 30 centimeter mark, which I already did. As you can see, it is on the left side. And then on the right side, I have a 200 gram mass. Now, on your lab report, you do need to draw a free body diagram to solve for it, because the missing information is the location of that 200 gram mass. Be aware, as you can see, I use strain to hand the mass, which means the mass of the strain is also involving this calculation. And each strain I already pre-cut and also pre-measure it. It is about 0.08 grams. And throughout this whole lab activity, all the mass of the strain is going to be 0.08 gram. So just keep that in mind. After the calculation, you should be able to find out the calculated location. So what I'm going to do next is placing that 200 gram to close to that number, but I might need to do some adjustment to make sure the whole system is balanced. So for this one, the actual location, what I'm seeing right now, is 60.35 centimeters. So that's what the actual location is. So record that data down. So for problem 2, I need to move the pivot point to 60 centimeter mark, which I already did. As you can see from the screen, as I'm showing you right now, the whole system is not balanced anymore because it's not at the center of gravity. So you do need to find out if I put a 50 gram of mass at 25 centimeter mark, how much do I need to hand there at the 75 centimeter mark to make sure this whole system is balanced. Be aware you need to draw a free body diagram to help you out, because think about where the center of gravity, so actually there is a force of gravity involved in this diagram. So after I did the calculation and then putting on a strain, so be aware the strain, massive strain, is still 0.08 grams. And this is what you see at the whole system. Right now it's not really balanced yet because you can still see it's a little bit crooked, so I still need to make some adjustment on it. And then I will tell you the actual mass is, and you need to calculate the rest of the things on your own. Problem number 3, I have 100 gram hanging at 20 centimeter mark, 50 gram hanging at 40 centimeter mark. And pivot points still go back to where the center of gravity is at. Now you need to find out through the calculation and free body diagram, where can I hand the 200 gram of mass to make sure this whole system is balanced. Then I will give you the rest of the data to help you to finish the calculation. As you can see, after my calculation, then I placed at 200 grams, around 67.5 centimeter-ish, and then do some adjustment. At the end, I got an actual location is at 67.75 centimeters. So here's the problem number 4. 500 grams is handing at 15 centimeters mark, and 100 grams is handing at 55 centimeter mark. You need to find out what is the mass to hand out at 70 centimeter mark. Right now, the center or the pivot point is actually at 30 centimeter mark. So it's a relative similar as number 2 you're doing. So you need to consider the center of gravity as force of gravity at their original point. So please draw a free body diagram and you should be able to find out what is the mass that you need. And the mass of the strain right now is still calculated as 0.08 grams. And after this, I will give you the data for the actual mass, so you should be able to finish the rest of the data.